All right, so today we're going over simple versus compound interest. Very similar to some things we've done in the past. Okay, let's start with simple interest. Okay, and simple interest is going to mimic basically a linear function. Okay, so where a linear function usually has the equation y equals mx plus b. Really using the exact same formula, we can say y is going to be your, we'll call it your current amount. M is going to be how much you are adding each month. You're going to multiply that by time. Usually for simple interest, it is years. And then we're just going to add our initial investment. So the only tricky part is really kind of figuring out how much you're adding each month. Okay, if you're given a chart, it's pretty easy. You can just kind of follow the chart. If it's not a chart, you might have to figure it out. So we'll take a look at two different kind of examples. One where maybe you're given a table. So like years. Okay, and then how much money you have. So we'll just do the first couple of years. So year 0, let's say you have 500. Then the next year, 550, 600, 650. Okay, so if you want to write an equation that fits this model, okay, we got to identify what are we adding between each year, and each year we're adding $50. So your current amount, Y, is going to equal 50 call time X, and we add our initial investment of 500. Okay. So if you wanted to figure out how much would you have in, we'll say 30 years. Okay. Obviously, you could just keep making a table, make it go on and on. I picked 30 because it's kind of long and that would take a while to figure out. Or we can plug in 30 for X. So we got 50 times 30 plus 500. So in 30 years, we'd have $2,000. So given table, it kind of tells you, maybe they give you a percentage instead. It's a little bit trickier. Let's say you invest $800 at, we'll call it 10%. Simple interest. And we want to see how much we'll have in 15 years. So we got to figure out we got to figure out how much essentially we'll have after that first year. Okay, so we want to find out what is 10% of 800. And you can plug 800 times 0.10, and it should be equaling 80. So this is what you are adding each year. Okay, so we had $80 being added each year. Our equation y equals 80x plus our initial investment of 800. That's where we'd want to plug in 15 for years. Well, that's weird. Did not mean to do that, but it ends up being the exact same as the previous example, where after 15 years, you would have $2,000. Just a coincidence that it's 2000 again. So I don't think that it's always going to be the case. All right, so simple interest, find out how much you're adding from one year to the next. Okay, just keep adding that, so on and so forth. It's pretty simple. Compound interest, a little bit more complicated. Because it's an exponential function. You're not adding the same amount each time. So again, I'll try and write a really long equation here where we have our current amount in our account. Okay, that's going to be equal to our initial investment times 1 plus our interest rate divided by number of compounds per year raised to number of total compounds. Okay, and usually that's our years times how often we're compounding per year. Let's put a hash pound number sign. Okay, so if you're doing it yearly, okay, these two numbers are just going to be one, and it's pretty simple. So let's say you had an initial investment of $1,200, a rate of 5%. Yearly compound, so we're just compounding once per year. And then length, we'll just set it at 10 years. All right, so you need all this stuff. So if we want to find out how much we'll have after 10 years, y equals our initial investment of 1,200, 1 plus our interest rate, 5%, written as a decimal, 0.05. Really, we're dividing by 1. You don't need to write that, but you can. Okay, number of compounds per year, so 1, and we're doing that for 10 years. Again, you don't need the ones. Okay. If we wanted to clean up the equation, it's just 1.05 raised to the 10th. This comes out to be $1,200 or $2,000. I'm gonna lose my mind. 1.05 raised to the 10th. Geez, somewhat close. So after 10 years, you'd have $1,954.67. Okay, so compounded yearly, you just put ones in there, it's not too hard. Other, you can compound monthly. Which means 12 times a year. Weekly would be 52. Daily would be 365. And then you can kind of go quarterly. You can pretty much pick whatever number you want. I mean, quarterly is going to be 4. You could say bi-yearly. Should be 2. Okay, so you got all these different kind of options. So let's say we have an initial investment of $3,000 at a rate of 3%. Let's say we're going to compound. We'll do monthly. And let's say it'll be for 8 years. So got our initial investment, 3,000. That's the easy part. Okay, so the tricky part here, we turn our interest rate into a decimal, so 0.03. Okay, now we have to divide that by how many compounds we have a month. Compounded monthly means we got to split it up over those 12 compounds. Okay, we're doing it for 8 years. And we use that same number up here because we are going to compound 12 times a year for 8 years. Okay, now you can type all that into a calculator fairly easily. Yeah, you could also clean it up before you put it into a calculator. So I'll do that. 0.03 divided by 12 means my new multiplier is 1.0025. And 8 times 12 is 96. So 3,000 times 1.0025 raised to the 96 power means after 8 years, okay, my investment is now worth $3,812.61. All right, we'll do one more. Initial investment. Let's say I'll keep the numbers small. Let's say initial investing $20. Hey, let's say we have a rate of 5%. Let's compound quarterly. Okay, means we're going to compound 4 times a year. And let's say we're going to do it for 6 years. So initial investment, $20. 1 plus our interest rate as a decimal. Compounding quarterly, so we got to divide that by 4. Okay, and then we have, we're going to do it for 6 years, 4 times a year. Should be 24 up there. So y equals 20. We can simplify our decimals and things over here. 0.05 divided by 4. So 1 plus that 1.0125 raised to the 24th power. So after 6 years, our $20 is now worth $26.95. Fun stuff.